Hello. Today we're going to go over the last of the three trigonometric ratios, which is called tangent. And then we're going to start using algebra and those trig ratios to find the missing sides of a triangle, of a right triangle, I should say. So, first off, in recap, we had our sine of theta, of whatever that reference angle is the opposite side length over the hypotenuse. And our cosine of theta was the adjacent side over the hypotenuse. And that all came from our right triangle, where we had a reference angle here. This is our opposite side. This is the hypotenuse, and this is the adjacent. Okay, so when we were looking at that, the opposite was there, the adjacent there, and the hypotenuse is there. And we had our reference angle here. Okay, so the last one is going to be called tangent. And tangent is no different than sine or cosine in terms of how it's just a ratio between two sides, except that the tangent of theta is going to be the opposite side over the adjacent side. So what we're really dealing with here is just the opposite over the adjacent given a specific reference angle. So there's three different ratios, and so we can just take a look at one triangle here. So for instance, if this was side 3, 4, and 5, and let's say our reference angle was there, we could find the sine of theta, the cosine of theta, and the tangent of theta. So there's my reference angle. That means 4 is the opposite, 3 is the adjacent, 5 is the hypotenuse. And again, you can just quickly label these. I usually do too. So that's my adjacent, that's my opposite, that's my hypotenuse. So, as we said, sine is opposite over hypotenuse. So this one is just going to be 4 over 5. Cosine is adjacent over hypotenuse. So that one's going to be 3 over 5. And now tangent. And tangent up here that we just stated is my opposite over adjacent. So that one's going to be 4 over 3. So sine, cosine, tangent are all pretty much similar. They just have different ratios. And so we need to remember what those ratios are when we're using them, because we're going to start using these to solve for missing sides and missing angles in a right triangle. And so we want to make sure that we have the correct ratio. Otherwise, our answers and our similar triangles won't work anymore. So there's an easy way to remember all of these three, okay? Because they're all kind of confusing using the same parts. And it's called SOHCAHTOA. And where that comes from is that sine is opposite over hypotenuse. Cosine is your adjacent over hypotenuse. And your tangent is the opposite over adjacent. And you can see sine, opposite over hypotenuse. Cosine, C, adjacent over hypotenuse. And then our tangent, opposite over adjacent. And that's where we get these in a nice little easy way to remember it called SOHCAHTOA. And I always write this down in my notes. I write it down on the top of quizzes. I try and write it down everywhere so I don't forget it. It's a really easy way to keep yourself from making simple mistakes. So, this SOHCAHTOA is very important to remember because it can really help make sure that you don't make an error and use the wrong ratio or mix things up. And that's all three of those ratios that we're going to be using for the rest of the year. Okay? Because trig is our last unit of the year, and so SOHCAHTOA plays a huge part into that. All right? So, now we're going to get into solving for missing sides. And so when we're solving for missing sides, we need to make sure we're using the right ratio, and then we're going to use some algebra to solve for it. So there's a two-step process. We need to set up the correct ratio using SOHCAHTOA. And then we need to solve for x using algebra. And we will need a calculator. And usually your iPhone or anything like that, a scientific one, will have that on that. So let's get to that. So here's one example. We have our right triangle. And now we're going to be using an actual angle instead of theta, because this is all going to come into play here. So, for instance, I have this angle here is 60 degrees. And let's say that my hypotenuse has a length of 12. And I want to know what x is. So, let's take a look at what we have. Right now we have a reference angle of 60. We have a hypotenuse of 12. And we have this unknown down here, which is our adjacent side. So we're trying to solve for the adjacent side. So I have adjacent and I have hypotenuse. So if I go back up to my ratios, the only one that deals with adjacent and hypotenuse is right here. The other ones have opposites in them, and we don't know the opposite side yet. So I need to use my cosine. So the way I set this up is I'm going to say cosine of angle 60 is equal to, I don't know the adjacent, so that's my x, over the hypotenuse, which is 12. So you can see we're not changing anything except we're just using numbers, and now our unknown is that 12. Or sorry, is that x, which is the adjacent side. So here's where you're going to use your calculator, because obviously we don't know what cosine of 60 degrees is. So we need to make sure that we can plug that in. And so in your calculator, there's a button for sine, cosine, and tangent. So what you're going to do is you're going to plug in the cosine of 60 into your calculator, and that's going to give you a decimal. And so if we look, let me get my calculator brought up here. Oops. Okay. So there it is. Okay. So on my calculator, if I hit 60 and then hit cosine, I get 0.5. And that's equal to x divided by 12. So to get x by itself, we're just using our basic algebra now. And so if x is being divided by 12, I need to multiply that by 12. That's going to cancel those out, but I have to multiply this side by 12 as well. And so 12 times a half is 6. And so that missing side of x is 6. I'll give you a second to kind of process that. And again, feel free to hit pause at any time when you're taking these notes so you can kind of see what's going on and try and make that happen. There is one very important note that you need to do is on the calculator. The calculator needs to be in degrees mode. Usually on your calculators, there's a little mode button. And if you hit that, it'll switch it from degrees or to radians. We're going to be using degrees the entire year. So just make sure that's in degrees. And you can quickly tell by looking at your calculator right now, if you did not get this 0.5 when you hit cosine of 60, then you're in radians mode and you need to switch that back to degrees. Every single calculator should give you 0.5 for the cosine of 60. If you're getting anything different, that means you're in the wrong mode and you need to switch that. And once you switch it, you're done. You can just leave it in degrees for the rest of the year. We're not going to deal with radians. And that's all you have to do. So again, so the two steps are, we need to set up the correct ratio using SOHCAHTOA, given what we have in the triangle, and then just need to solve for x using our algebra. And that'll involve you using the calculator too. So let's do another practice problem here. So I have my triangle, and I'm going to have a degree here of 40 degrees. And I have a hypotenuse of 22. And my x is down here. So I'm trying to find that bottom side length. Well, if we go through and label these, this is my hypotenuse. This is my opposite. And here is my reference angle. So if we look at our ratios, which trigonometric ratio uses the opposite and the hypotenuse? Well, that's going to be our sine. If we go back up here, you can see sine has opposite and hypotenuse. So I have the sine of 40 degrees is equal to the opposite over the hypotenuse. In my calculator, I hit sine of 40, and I get a decimal of 0.642787, blah, 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 blah. So we're going to round that to 0.64. So we're going to round that to 2 decimal places. So sine of 40 is 0.64 equals x over 22. I multiply by 22 to get those to cancel. And so I have to multiply 0.64 by 22 as well. And if I do that on the calculator, I get 14.08 is approximately x because we rounded it. And that's all I have to do. Again, very important that your calculator needs to be in degrees. If you didn't get that 0.64, that means you're in the radians, so make sure you switch that, because every time you do sine of 40, you're going to get 0.642, blah, blah, blah. That rounds to 0.64. All right, so let's do some practice problems here. And again, your triangles are going to look different every time. It doesn't matter where they're at. All we need to know is that they're right triangles. So on this one, we're going to have a degree of 35. And we're going to have to solve for x. And we have this as 10. On this one here, this is going to be 20 degrees. And we have a value of, we'll just say 5. And we're looking for x. So on this one here, again, let's remember, always write that by your problems that you're working on. We need to use our SOHCAHTOA to use the right trig ratio. So on this one, we have our adjacent side, and this is our opposite side. So on this one, we're going to be using tangent, because we have opposite and adjacent. So I have the tangent of 35 is equal to 10, because that's my opposite, over x. So let's go to the calculator and hit tangent of 35. And you should get 0.70, which is just 0.7, equals 10 over x. So the algebra is going to be a little bit trickier on this one because we have our variable in the denominator, but really it doesn't change much. It just adds one step. So I'm going to multiply by x on both sides. That's going to cancel that. And now I have 0.7x equals 10. Well, to get x by itself, I just have to divide by 0.7. Because that's going to cancel these on that side. And now x is by itself. And 10 divided by 0.7 on your calculator is 14.29. Always round 2 decimal places on this. And that's our solution. So again, if you have a variable in the denominator, you're going to have to do one extra step. You're going to multiply by the x, and then you're going to divide by what's on the other side. And that's still going to give you the same answer you should get. Okay, let's do the next problem here. So on this one, if we go ahead and label, this is the hypotenuse, this is my adjacent. Remember, we're always doing that in reference of the angle given. So if I have the adjacent and the hypotenuse, I'm going to be using cosine. So I get cosine of 20 degrees equals x over 5, because it's that adjacent over the hypotenuse. My calculator says that the cosine of 20 degrees is 0.94. And that's rounded 2 decimal places. It's a much longer decimal. I need to multiply each side by 5 to get that to cancel. And now I have 5 times 0.94 which gives me 4.7. Okay, and that's it. That's our missing side. So the big thing again is using that SOHCAHTOA to find the right ratio. And then once you have that right ratio set up, you just have to use your calculator and the algebra to undo it to get your x by itself. If you have questions, please email me. The assignment today is going to be more of finding the right ratio in the first part, and the second part is going to be about solving for these missing sides. So it's going to be kind of a replay of what we did last class, just setting those fractions, and then the second part is going to be solving like we did today. So if you have questions, again, feel free to email me or contact me so that we can get you help if you need it. If you get answers wrong, try them again, because the Go Formative will tell you what the right answer is. And if you know the right answer, you can then set it up and try again and see if you can get it and see if you can maybe find where that mistake was. If not, email me and we'll go through it.